Before starting, I want to introduce the subject. Basically, the topic which are given to me for this talk, where principles working and application of colorimetry, spectrophotometry, ultracentrifugation, ultra fluorescence, X-ray diffraction. Basically, these are basically the tools or techniques which is essential for uh, mainly biomedical biochemistry, pharmaceutical sciences. Basically, I am from pharmaceutical background, so just these tools or techniques or these basically instrument which are utilized for the detection of various compounds, either we use as a drug, either we use as a uh, compound for our future investigation. I'm audible to all. I'm audible.
Yes, sir.
So in the first slide, we mentioning the various techniques, analytical techniques, and mainly gravimetry here. What the major thing is the weight of pure annihilate or compound of known stoichiometry. Principal area of applications quantitative for major and minor component. This technique is utilized for detection of major or minor component. Then trigonometric analysis, volume of standard reagent solution reacting with the annihilate. Here, quantitative for major and minor components are detected. Another technique, atomic and molecular spectrometry. Here, wavelength and intensity of electromagnetic radiations emitted or absorbed by the annihilate. Here, qualitative, quantitative, or structural for measure down to trace level components are detected. मास स्पेक्ट्रो अच्छा एक चीज बताइए आप लोग थोड़ा सा मैं पूछना चाहता हूं बिफोर आई गो इन डिटेल कि बेसिक आप लोगों ने थोड़ा पढ़ रखा है कि नहीं इस सब से सब्जेक्ट से रिलेटेड
Yes, sir.
क्या क्या अच्छा सम्रा फर्स्ट वन कौन क्या नाम है आपका रेहान जी
Yes, sir.
बेटा आपका क्या बैकग्राउंड क्या था पीजी का
सर मैंने zoology में एमएससी किया है.
जियोलॉजी जूलॉजी
Yes, sir. Yes, sir.
अच्छा तो ये बेसिक जो टूल्स हैं ये सारे आपने कहीं पढ़ा है इससे पहले कि नहीं पढ़ा
जी सर पढ़ा हुआ है. सर मैंने जेआरएफ
हाँ
क्वालिफाई किया है तो उसकी प्रिपरेशन के लिए पढ़ा था.
हाँ तो ये सारी चीजें बेसिकली आपने पढ़ा ही होगा क्योंकि एंट्रेंस में ये सारी चीजें आती हैं और जो
जी सर.
आपका मेडिकल बायोकेमिस्ट्री सब्जेक्ट है इसमें बेसिकली आपका यूटिलाइजेशन मेनली जो क्रोमेटोग्राफिक टेक्निक्स हैं या आपका जो इलेक्ट्रोफोर्सिस वगैरह है वो सारी चीज का एप्लीकेशन बस लेकिन ये इनका जो बेसिक है इन सब इंस्ट्रूमेंट के बारे में बेसिक नॉलेज और इनका जो क्या इंस्ट्रूमेंट के जो वेरियस कंपोनेंट्स होते हैं और क्या डिटेक्ट करते हैं ये सारी चीजें हमारी नॉलेज में होना चाहिए है ना
ओके सर.
एक सेकंड तो mass spectrometry here the mass of compound are detected chromatographic and electrophorese various physicochemical properties of certain inlet thermal analysis electrochemical analysis radiochemical analysis these are the various techniques and the where here the various property used and the mainly principal area of applications are traced out. Another table shows the spectrometric techniques and principal application, plasma emission spectrometry, atomic emission after excitation in high temperature glass plasma, applications, determination of metals and some non-metals, mainly at trace levels, flame emission spectrometry, atomic emission after flame excitation, determination of alkali and alkaline earth metals, atomic absorption spectrometry, atomic absorption after atomization by flame or electrothermal means, here detection of trace elements, metals and non-metals, atomic fluorescence spectrometry, X-ray emission spectrometry, gamma spectrometry, UV and visible spectrometry, infrared spectrometry, NMR, mass. These are the various techniques and the basis of their detection, the principal application where we use these modern techniques or tools. As the separation techniques are taken into consideration, TLC, GC, HPLC, electrophoresis nowadays, HPLC, HPTLC, UPLC is nowadays very common. So these are the techniques basically based on the principle of chromatography, जहाँ पे क्या करते हैं हम मोबाइल फेज और एक स्टेशनरी फेज दोनों के बेस पे हम उसका डिटेक्शन करते हैं कि कौन सा कंपाउंड हमें क्या उसको आइसोलेट करना है, सेपरेट आउट करना है, और फिर उसके बाद उनका जो स्ट्रक्चर इल्यूसिडेशन में हमारी सारे टूल्स होते हैं, जैसे उसका आईआर क्या है, एनएमआर क्या है, मास क्या है, वो सारी चीजें हम डिटेक्ट करके फाइनली क्या स्ट्रक्चर पॉसिबल है उस कंपाउंड का, अगर हम कोई नए कंपाउंड को डिटेक्ट करते हैं. In this particular table, selection of most appropriate analytical method, the purpose क्या होना चाहिए analysis का, how much time, scale and cost constraint, level of annihilate expected and detection limit required, nature of sample, amount of available and necessary sample preparation procedure, accuracy. These are various things are utilized for the detection of compound or analysis. So sir, let us come to our own topic, colorimeter. Principle, working and application of colorimeter. Basically it is a device that is used in colorimetry. Refers to a device which helps in specific solutions to absorb a particular wavelength of light. The colorimeter is usually used to measure the concentration of known solute in a given solution with the help of Beer-Lambert law. The colorimeter was invented in the year 1870 by Louis Dubois. What is the basic principle of colorimetry? As the photo, it is a photometric technique which states that when a beam of incident light passes through a solution, the following occur. Some part is reflected, some part is absorbed, some part is transmitted, and overall these are accumulated. Then what the source we use for some part is reflected, some is absorbed, some is transmitted. Overall it gives information how much it is reflected, how much it is absorbed, how much it is transmitted. To determine IA absorbance, the measurement of IO and IT is sufficient, so IR is eliminated. Colorimeter is based on two fundamental laws, Beer's law and another is Lambert's law. And what the Beer's law says, according to this law, the amount of light absorbed is proportional to the solute concentration present in solution. Log 10 IO upon IT, it's equals to AS dot C. AS is the absorbency index, C is the concentration of solution. Another law used in colorimetry, Lambert's law. According to this, amount of light absorbed is proportional to the length as well as thickness of solution taken for analysis. Here A is test absorbance of test, AS is standard absorbance, B is the length or thickness of the solution. This diagram shows how colorimeter works. Here, what happened? We choose a source of light and passes light to polychromatic light passes through a slit, and this slit passes the light, and through a lens it goes to a solution or through filter, and the solution, when the light passes through the solution, some part is reflected, some is absorbed. What it is absorbed is detected by photoelectric cells, and the galvanometer only finally detects the peaks or the absorbency in a ratio. But how it works? Before starting the experiment, it is important to calibrate the colorimeter. क्योंकि कैलिब्रेशन इज इंपॉर्टेंट थिंग. कैलिब्रेशन हम क्यों कर रहे हैं किसी भी इंस्ट्रूमेंट का? कैलिब्रेशन इसलिए है कि what the results are coming, it is right or wrong. अगर हमने मान लीजिए कोई इक्विपमेंट हम लैब में यूज कर रहे हैं कि टेम्परेचर हमने 40 डिग्री सेंटीग्रेड दी, क्या वो 40 डिग्री सेंटीग्रेड ओवन दे रहा है हमारा? तो इसका टाइम टू टाइम इसका कैलिब्रेशन और वैलिडेशन भी हम करते रहते हैं इक्विपमेंट का. और अगर वो चीज ठीक है, हमारा वैलिडेट है इक्विपमेंट, उसके फंक्शंस सारे ठीक हैं, तो हम उसको मानते हैं कि इट इज वर्किंग प्रॉपरली. तो it is done by using a standard solution of the known solute concentration that has to be determined. Here, the fill the standard solution in the cuvette. Cuvette are the cubes like this one, tubes, where we put our sample for detection, how much it absorbs light, how it reflected, or how much it is transmitted. On the basis of absorbency, we get the desired lambda, or on the basis of wavelength, we detect the range of our compound need for detection. Or it on the basis of that, we study how our colorimeter works. A light ray of certain wavelength is specific for the assay in the direction of solution. When the light passes through a series of different lenses and filter, the colored light navigates with the help of lenses, and the filter helps to split a beam of light into different wavelengths, allowing only the required wavelength to pass through it and reach the cuvette of the standard test solution. Step third, when the beam of light reaches cuvette, it is transmitted, reflected, and absorbed by the solution. The transmitted ray falls on the photodetector system, where it measures the intensity of transmitted light, which is this intensity is important for our detection purpose. It converts it into the electrical signals and send it to the galvanometer. Then finally, the galvanometer signal measured by the galvanometer are displayed in digital form, and the formula which is used for the detection of its absorbency, A equals to epsilon Cl. Ct is the concentration of test solution, Cs is the concentration of standard solution, and As is the absorbance or optical density of standard solution. What is the use of colorimeter? Basically, this is used in laboratories and hospitals to estimate biochemical samples such as urine, cerebrospinal fluid, plasma, serum, etc. Used in manufacturing of paints, used in textile and food industry, used in the quantitative analysis of proteins, glucose, and other biochemical compounds, used to test water quality. It is used to determine the concentration of hemoglobin in the blood. What are the advantages and disadvantages of colorimeter? Some advantages are here mentioned. It is an inexpensive method, widely used in the quantitative analysis of colored sample, easy to carry and transport, but few are disadvantages with colorimeter. It analyzes only colored compound. Colorless compound detection is not possible through this instrument. Only colored compound can be detected. This is the main drawback of colorimeter, and it does not work in infrared and UV regions. Next, difference between spectrophotometer and colorimeter. Because the colorimeter is used only for detection of colored compound, and for colorless compound we generally use spectrophotometer. Spectrophotometric analysis, where UV visible spectrophotometer, IR spectrophotometry, or FR spectrophotometry, or these are based on their range of wavelength the compound shows. In order to have objective measure color characteristic, colorimeter is used on only for color sample. A spectrophotometer is a photometer instrument for detecting intensity of light that can determine the intensity or more precisely the wavelength of light as a function of color. How colorimeter is useful in a real world? To track the growth of bacterial or yeast colony, colorimeter are commonly used. When used for the evaluation of color in bird plumage, they have accurate and extremely detailed results are coming out. They are used in various food and drinks, including vegetables product and sugar, to quantify and track colors in the solution. So this is all about for principles and application of colorimetry. जहां तक मैं समझता हूँ ये सारी चीजें आपने बेसिकली पढ़ रखा है. जनरल इंस्ट्रूमेंटेशंस आर अवेलेबल इन वेरियस बुक्स आल्सो, और इनका प्रैक्टिकल अप्रोच क्या होगा वो सारी चीजें हमें पे ध्यान देना होगा, जो आप आगे चल के अपनी पीएचडी क्लास में करोगे. जब आपका कोई टॉपिक डिसाइड होगा तो बेसिकली एक एम होता है हमारा कि हमें क्या चीज को करना है. रिजल्ट्स आइदर इट कम्स इन पॉजिटिव फॉर्म और नेगेटिव फॉर्म, बट रिसर्च इज एन ऑब्जेक्टिव हम लेके चलते हैं कि ऐसा नहीं है कि जो हम सोच के चल रहे हैं कि अगर पॉजिटिव रिजल्ट आ रहा है तो ही रिसर्च है, नेगेटिव है तो वो हमारा रिसर्च नहीं है. हमको दोनों चीजें करनी है कि हो सकता है कई बार नेगेटिव रिजल्ट से भी हमें बहुत सारी चीजें ऐसी मिल जाती हैं कि जिसका कोई और यूटिलाइजेशन करके उस पर हमारा मनी ना वेस्ट करे, उस पर पैसा इस और जो प्रोसीजर फॉलो करें उससे पता चल जाता है कि इससे हमारी रिजल्ट को डेविएशन हो रहा है तो उसको हम फॉलो नहीं करते. तो ये तो हमारा जनरल इसका था. बाकी नेक्स्ट क्लास टुमारो या डे आफ्टर टुमारो हम आपको बता देंगे कि स्पेक्ट्रोफोटोमेट्री और में क्या क्या करना है, क्योंकि आपकी नीड के हिसाब से स्पेक्ट्रोफोटोमेट्री तो बहुत डिटेल्स में है कि हमारा उसमें क्रोमेटोग्राफिक शिफ्ट है, कैलकुलेशन कैसे लैम्डा मैक्स कैसे कैलकुलेट करते हैं, और ये स्टैंडर्ड सोल्यूशन कैसे प्रिपेयर करते हैं. स्टैंडर्ड सोल्यूशन प्रिपेयर करने के बाद यूवी स्पेक्ट्रोफोटोमीटर में डिटेक्ट कैसे करते हैं. तो उसके जो भी अप्रोचेस हैं थ्रू कैलकुलेटिव पार्ट, तो वो सारी चीजें आपके लिए कितना यूजफुल है या नहीं एक बार मैं देख लेता हूँ. तो उसके बाद फिर हम उसको डिजाइन करते हैं कि आपकी नीड क्या है, क्योंकि मेनली आज की डेट में स्पेक्ट्रोफोटोमेट्री का भी यूज कम है और एडवांस जो इंस्ट्रूमेंट्स हैं हम उस पे उसका यूटिलाइजेशन करते हैं. तो आज इतना ही कंप्लीट करते हैं, बाकी नेक्स्ट क्लास में देखते हैं. ठीक है. आई एम ऑडिबल?
यस सर.
तो बेटा ये आज का इतना ही रखते हैं, बाकी कल देखते हैं. ठीक है.
ओके सर.
थैंक यू.
ओके, थैंक यू सर.